Welcome to the chemistry class, my dear students. I hope you all are fit and fine and you all are doing great. So, today we will be going to start our third chapter. Name of the chapter is electrochemistry. So, in class 11th, you learned about the redox reaction. So, what is redox reaction? Redox reaction. See, it is made up of two words, that is reduction plus oxidation. The reactions in which reduction and oxidation reactions occur simultaneously are your redox reactions. And it has very much important in electrochemistry. So, the reactions in which reduction and oxidation reaction occur simultaneously is your redox reaction. So, first we should know what is reduction and what is oxidation. What is reduction and oxidation? I'm telling you these two terms with difference. Reduction and reduction. So, what is the difference between these two? First, oxidation. That is addition of oxygen is your oxidation. And reduction, addition of hydrogen. If in any reaction, hydrogen is being added, that is reduction. And if oxygen is added, that is oxidation. Or if removal of hydrogen takes place, that is also oxidation. And if removal of oxygen takes place, that is also reduction. But you all are aware from these topics because you have already discussed these things in class 10th, class 11th also. Class 11th, main redox reactions complete chapter is there. Third, very important, that is loss of electrons is your oxidation, and it is gain of electrons. It is very important. Oxidation is loss of electrons and reduction is gain of electrons. How you will remember? Remember by word Ola. Ola over. So, Ola means oxidation, loss of electrons. Because my dear students, you will definitely get confused that either oxidation is loss of electrons or gain of electrons. So by remembering the word Ola, okay, so it is oxidation is loss of electrons and reduction is gain of electrons. Fourth most important definition, increase in oxidation number is your oxidation and decrease in oxidation number is your reduction. For example, if I am taking ethene in which hydrogen is being added in the presence of palladium, it will be converted into ethane. So in this, hydrogen is being added. So this is the example of reduction. Now, if I will take Like chlorine, it is, no, I will take zinc. It will gives you, suppose, so here loss of electrons takes place. So this is your oxidation. I hope is it clear to you? Oxidation is gain of oxygen, removal of hydrogen, loss of electrons, increase in oxidation number, like from oxidation number 0 to +2. Oxidation number is being increased. So that is your oxidation. And reduction is addition of hydrogen, removal of oxygen, gain of electron or decrease in oxidation number is your reduction. Now, always remember, if reduction is going on in a particular reaction, then there must be oxidation reaction also going on simultaneously. And they are known as redox reactions, in which reduction and oxidation reactions occurs simultaneously. Now you will came to know why I have discussed this thing, because it is very important in understanding the concept of electrochemistry, because in this redox reactions are taking place. So now come to our chapter. First, I will tell you what is electrochemistry. Electro means electrical energy, and chemistry means chemical energy. So the branch of chemistry that deals with the, which deals with the electrical energy and chemical energy, which deals with electrical energy and chemical energy, and what is the quantitative relationship between them. So that branch is your electrochemistry, which deals with the relationship between electrical energy and chemical energy. Or you can say that how the chemical energy produced in a particular redox reaction can be converted into electrical energy, or how our electrical energy can be used to bring about a chemical change. Okay, so it deals with these two energies. What is the relationship between them? How electrical energy can be converted into chemical energy, or vice versa. This is your electrochemistry. Now, in electrochemistry, you have to deal with three main subjects. That is electrolysis, your electrolytic conduction, electrolysis, your electrochemical cell, and electrolytic conduction. We will discuss all these things. Now, what is the importance of electrochemistry? What is its importance? See, there are a number of metals like sodium, magnesium, calcium, sodium, magnesium, calcium, and certain chemicals like NaOH. They are commercially produced by the electrochemical methods. Fine? How they are produced? With the help of electrochemistry. Batteries and cells, which we are using in various instruments and devices, that converts chemical energy into electrical energy. The most important function in our body is the sensory signals sent to the brain through the cells, or from cells to the brain, Or in short, I will say communication process in our body is based on electrochemical phenomenon. So electrochemistry has a vast importance in our daily life, even in our body also. I hope the meaning of electrochemistry and its importance is clear to you all. Is there any doubt? Then please let me know. My dear students, there are so many ways for the production of electricity, like wind power plant, thermal power plant, hydraulic plant, nuclear plants. They all are used to produce electricity. But very common way and easy way of producing electricity is your electrochemical cell. So electrochemical cell, in this we will be going to know about how the electricity is produced from chemical reactions. Okay, so electrochemical cell is a device which is used to convert chemical energy, as the name says, chemical energy into electrical energy. So it is a device which is used to convert the chemical energy of reactions into electrical energy. Fine. So what is electrochemical cell? The cell which is used to convert electrical chemical energy into electrical energy. And this cell is based on redox reactions. And that reactions should be spontaneous. Spontaneous means which can occur, which should be feasible in nature. Okay? So what is electrochemical cell? The cell which is used to convert chemical energy into electrical energy, and that reactions should be redox and spontaneous in nature. Fine? Now, there are two types of electrochemical cell, galvanic cell and electrolytic cell. In this, electrolytic cell, the electrical energy is converted into chemical energy, and they both constitute your electrochemical cell. So first we will discuss about our galvanic cell. First is galvanic cell. Galvanic cell. See, there are three components of galvanic cell. That is oxidation half cell. As I already told you, it is a redox reaction, which means reduction and oxidation process is going on. Reduction half cell. And third one is your salt bridge. See, oxidation half cell, reduction half cell, and salt bridge. First, I'm going to tell you about oxidation half cell. As the name says, in which the part of the cell in which oxidation reaction is going on. Suppose I am taking any beaker in which one metal electrode is present. It is represented by M, any metal. Okay, this is one beaker in which metal electrode is present. And remember, suppose I am taking zinc rod. So in that, it has to be dipped in the electrolytic solution of the same metal. Like if I am dipped in, I am taking copper, then it should be placed in copper nitrate, copper sulfate, which means The electrolytic solution should contain that metal in its formula. This is metal M. This must be present in its electrolytic solution. So, suppose in this metal which is present in solid state, it will start losing its electrons and form Mn plus electron. So, from here, the metal will be converted into, metal solid will be converted into metal plus any charge, whatever the charge present on that, plus aqueous, plus electron will start flowing because this electrode is connected to any wire. This metal, because it is metal, it will start losing its electron. That electron will move, move through the wire, and metal in solid state is converted into metal in aqueous state having positive charge. So my dear, what will happen? Here the accumulation of positive charge is more than this electron. And you will see there is a charge difference generated. Here the positive charge in the solution is more than that of the electrode. So due to this charge difference, there is a development of some kind of potential. So potential difference is generated, which is due to this charge difference because metal is losing the electron. As here oxidation reaction is going on, so that potential name is named as oxidation potential, or I'm writing it as OP, which is represented by E. Okay, E is your oxidation potential, which is developing due to the charge difference here. Fine. If I'm taking this reaction in standard conditions, which means the concentration of this solution is 1 molar, pressure is 1 bar, at temperature is 25 degrees Celsius. In standard conditions, if the reaction is going on, that potential must be represented by E naught. Naught means in standard condition. So that is the standard oxidation potential. Standard oxidation potential means the potential generated in standard conditions. Fine. So in that case, what is going on? What is going on here? Metal is converted into charged species in aqueous state. My dear, what is this represents? This single forward slash represents the phase difference. Because here metal solid is converted into aqueous. Its phase is changing. You might be remember this term from redox reactions in representation of cell. So that's all about your oxidation potential. Similarly, as it is redox reaction, so there must be reduction process going on in another beaker. Suppose this is another beaker. This is the second component, that is reduction half cell. In which also electrode is present. Now the electron from oxidation side comings and reduction is gain of electrons. What will happen? Suppose I am taking copper here, suppose, and it is present in copper plus 2 form, it will easily take this electron and convert it into copper. So again, here negative charge is more, then here negative charge is less. Similarly, due to charge difference, there must be a potential difference generated here, which is known as reduction potential difference. Fine. And in this, what's going on? Suppose copper will take 2 electrons and form copper. So gain of electrons is reduction. Fine. Now, one more thing you should remember, salt bridge. Third component of this cell is salt bridge. Salt bridge is a U-shaped tube which is having inert electrolyte. Inert means not reactive electrolyte like KCl, NaNO3, and it connects the two half cells to each other. Salt bridge is a U-shaped tube containing inert electrolytes in agar-agar medium. Agar-agar medium means they make it viscous. It contains inert electrolyte in agar-agar medium. Agar-agar medium is a gel-like substance which make the solution of inert the solution present in this U tube is viscous in nature. Okay. Now, what is the role of salt bridge here? What is its function? It connects two half cell. Suppose this is your oxidation half cell and this is your reduction half cell. I am taking the example of zinc and copper. As zinc is more reactive than copper, so it will easily loses its electron and it will be acting as, in this, oxidation takes place and in this, reduction takes place. It connects one half cell to the another half cell. This is its first function. Second, it completes the internal circuit. Fine. And it is helpful in increasing the, you can say that it is also helpful in stopping the liquid-liquid junction potential. Okay, so salt bridge is a U-shaped structure containing inert electrolytes, which is helpful in completing the internal circuit and it connects the two half cells. Okay, I hope is it clear to you? But remember, if any one of the half cell contains Ag plus, Hg plus 2 and lead plus 2, then the salt bridge containing KCl or NaCl should not be used because they will form the precipitates. Like NaCl, it will form like with Ag, it will form AgCl precipitates. So that is not good for your electrochemical cell. That's all about the setup of electrochemical cell. Now, if I go to the reaction side, that is connect to the battery. Here, it is connected to the negative terminal of the battery and it is named as anode. and it is connected to the positive terminal of the battery and it is named as cathode. My dear students, this is very important trick I am going to explain you, that is lone. Lone means left hand side, O means oxidation, A means anode, and N means negative terminal of the battery. With this, you will be able to learn the complete electrochemistry, otherwise you will forget what is anode, either it is positive or negative, either in this oxidation takes place or reduction, either is this left hand side or right hand side. So always remember in electrochemical cell, remember this word lone. Left hand side, oxidation, anode, negative terminal. So what's going on at oxidation? At anode, zinc loses its electrons, and at cathode, copper takes its electrons to convert it into copper. So what will be the net reaction? In net reaction, these electrons will cancel out and it will form zinc solid plus copper aqueous. It will be converted into Zn plus 2 and copper solid. This is the overall reaction. If I will say, write its cell reaction also in case of galvanic cell. So here, zinc solid with single phase converted into zinc plus 2 in aqueous solution. This double represents the salt bridge. You can write concentration also if it is given to you, and cupric is converted into copper. You can also write C1, C2 represents the concentration. Now this represents the oxidation. This double forward slash represents the salt bridge. This represents the reduction, and this single slash represents the phase change. Okay. Is there any doubt? Please let me know. Now one more thing. Remember few points. In electrochemical cell, electrode on which oxidation occur is called anode. An electrode on which reduction occur is called cathode. And very important point, electron flows from anode to cathode in the external circuit. Flow of electrons from external circuit is from anode to cathode. Okay, remember this point. It is very important. And inner circuit is completed by the flow of ions through the salt bridge. I hope this cell is clear to you all. Okay, if I will ask where the conventional current will flow, what is the direction? It is from cathode to anode or anode to cathode? What is the direction of current? Who will say? Okay. Jatin Betes, tell me, what is the direction of conventional current? It is from cathode to anode or from anode to cathode? Yes, Divya, you say, bete. Yes, very good. It is from, very good, Anish. It is from cathode to anode. Electrons will flow from anode to cathode and current from cathode to anode. Okay, my dear students. So in this lecture, we have started with introduction of electrochemistry, and then we have discussed about the galvanic cell. Is there any doubt to anyone? Please let me know. Otherwise, give me thumbs up. Is it clear to you?